The space is full of mysteries. Some of them are still unsolved, while some have already become well-known sensations. It's not a secret that most of them are related to the stars, which have always attracted both astronomers and those far from astronomy with their magnitude and inaccessibility. Our Milky Way galaxy is home to hundreds of billions of stars, and each of them is particularly unique. But it also has many neighbors, and the Large Magellanic Cloud is one of them. Even though it is smaller, and its diameter is 10 times smaller than the one of the Milky Way, it still may surprise any of us. This is the galaxy, hosting the unique binary stars VFTS 352, which have relatively recently been found by astronomers and have become an incredible astronomic discovery. Why is this star considered so special? Watch this video to get the answer. The first time these binary stars were observed was in October 2015 by an international group of scientists. And today, it's still one of the most curious and unusual binary stars known to humanity. To examine it, the scientists used the Very Large Telescope, the giant instrument of the Paranal Astronomic Observatory. It allowed scientists to see clearly that VFTS 352 is not just a star system, but an extreme binary system. The astronomers found these binary stars in the constellation of Dorado in the Tarantula Nebula, actively producing young stars in the nearby universe. By the way, this nebula possesses the most massive star discovered in 2020, which you may know as the R136A1. If you'd like to see a video about this star, write it in the comments. By the way, you all could have seen this pic or GIF. This computer model was designed exactly on the basis of the VFTS 352, and its objective was to show this system's uniqueness. You may often see these graphics even somewhere you don't expect to see any star system, which is quite an interesting fact. We've got a bit distracted, but now let's get back to the VFTS 352. There is a lot to tell about it, even though it's so distant from us. The distance between our planet and these binary stars is as much as 160,000 light-years. Both stars of this system are white and blue and belong to the spectral type O. They are very young, and, as a rule, the stars of this type are no older than a few million years. The stars of this type are rare, but their brightness makes them visible from a very long distance. The VFTS 352 system is unusually massive. Its common mass is about 57 solar masses, while its whole radius is about 7 solar radii. Meanwhile, the temperature of the star's surface may reach 42,000 Kelvin. Just to compare, the Sun's temperature is just 5,780 Kelvin. But actually, this star belongs to another spectral type. To measure separately the mass and temperature of each star are still quite challenging as the stars are too close to each other. But what is remarkable is that both stars are roughly the same size. It's really rare for the binary stars since usually a companion one is fueled by its bigger sister feeding off the star material from its surface, thus rejuvenating its own subsoil. We may call it star vampirism. Bright, massive, and extremely hot stars of the system VFTS 352 are characterized by the quite short distance between the centers of each object, which is only 7,458,048 miles. Speaking of the similar binary stars, this is quite a short distance, allowing them to adjoin their atmospheres, forming a kind of bridge. To compare, again, the distance between Mercury and the Sun is a bit less than 36,047,234 miles, which is almost 5 times longer. At the same time, to complete an orbit around the common center of gravity, the VFTS 352 system needs a bit more than 24 hours. Such a star system hasn't been seen ever before. The main reason is that this phase is usually passed by stars quite rapidly. That is why finding them requires quite an effort. As we speak about the binary stars, I'd like to make a little aside and briefly tell you that there are a lot of systems consisting not only of 2, but 3 and even more stars. Such systems we call multiple. For instance, one of the brightest stars in the night sky, Alpha Centauri, is a triple star system. Most multiple stars are binary, although there are systems including 5 or even more components. In the case of the VFTS 352, we have a contact binary system of stars bound with the gravity power and masses orbiting the common center. But in general, the components of binary stars are different in terms of their spectral type and physical parameters. That is why we usually divide the binary stars into 2 types: the stars with mass transfer and the stars without it. The first type, transferring mass from one to another component, is called a contact binary star system. Such systems are typically located deeply within their Roche lobes, the regions that have dominating the gravity of one of the binary system components. Each of them reliably keeps its material, preventing it from leaving the surface. As long as it works this way, each star of the system evolves as a single star. But in later life stages, one of the stars becomes 100 times bigger. As a result, there may be not enough space for it within its Roche lobe, so its mass starts transferring to another star, forming an interacting binary star. Roche lobes are bound to the stars, while the material which lies outside the Roche lobes creates a common Roche lobe overflow and transfers from one star to another. Therein lies another peculiarity of the VFTS 352 system. Thanks to the similar scale of stars, the material they need to exist is divided equally between them. It means that about 30% of the star material is common for the 2 components of the system. That is why we may often hear the word combination overcontact binary star system used for the VFTS 352. The mature close stars may have absolutely different life scenarios, and it's difficult to say how this or that system will end up. Astronomers suppose that the binary stars VFTS 352 may follow 2 scenarios. One of them leads to the merging of the 2 stars, resulting in the formation of a highly magnetized giant single star, while another one suggests avoiding merging the VFTS 352 components, which is possible if the star's masses are thoroughly mixed, and each star becomes a compact one. This scenario would be a new development path of a unique binary star, totally different from the usual evolution process. Most probably, the components of the VFTS 352 system will explode as supernovae and form a close pair of black holes emitting intense gravitational waves, which will later result in their emerging in one massive black hole. This evolution process may become a real sensation in astrophysics. But whatever it ends up with, the star system VFTS 352 has already made scientists look differently at the evolution process of massive overcontact binary stars. The stars are already poetized in many works, and who knows, maybe these overcontact binary stars will inspire poets to write new wonderful pieces, which will later become classics. But for now, they inspired the journalists to call this unusual and apparently unique tandem the kiss of the stars. And, you know, it makes sense. I think you'd agree that the stars are really special phenomena. And the sky full of stars is an indispensable part of romantic for those who are in love and are so inseparable as the binary stars of the VFTS 352.